10.3.2, ellipses centered somewhere else other than the origin. We're going to graph and write the equation of ellipses. The standard form of the equation of ellipse with the center at HK and major and minor axes of length 2a and 2b, where a is always greater than b and b is always greater than 0, is as follows. So it's very similar to the situation we had in the last lesson, only in the last lesson h and k were both 0 for their coordinates. So here we have x minus h quantity squared, y minus k quantity squared. That makes hk your center. If it is a ellipse that is being stretched more horizontally and the a squared is under the x portion, then your vertices are h plus or minus a, k, and co-vertices are h and then k plus or minus b. And if it is stretched the other way, then it is vice versa, obviously, with our x and y coordinates. Graph the equation. List the key points of the ellipse. We have x minus 2 quantity squared over 16 plus y plus 3 quantity squared over 25 equals 1. That means the center of our ellipse is at 2, negative 3. Since it's a minus h minus k in the equation, we change the signs that we see. Our a squared value is actually under the y portion. 25 is greater than 16. So a squared is equal to 25. That means a is plus or minus 5. Because our a value is plus or minus 5, and we know that this is elongated vertically since the larger number is below the y term, then that means we are going to be adding and subtracting 5 from the y coordinate negative 3 in order to get the vertices. So negative 3 minus 5 is negative 8, and then negative 3 plus 5 is 2. So let's go ahead and graph our center. 2, negative 3. Let's graph our vertices. 2, negative 8. 2, 2. Okay. Co-vertices come from our minor axis, our b value. And in this case, since b squared is 16, that means b is plus or minus 4. Since the minor axis is the smaller value, the b value is under the x coordinate, that means our minor axis is horizontal. And we are adding and subtracting 4 from the x coordinate of the center. So if the center is at 2, negative 3, then we subtract 4 from the x coordinate and we get negative 2, negative 3. And then we also get positive 6, negative 3 when we add 4 to that x coordinate of our center. So our ellipse looks something like this. We have yet to graph our foci yet. We have to solve for that. We know we get the foci from c squared equals a squared minus b squared. So in this case, 25 minus 16. So c is going to be plus or minus 3 because that's the square root of 9. The foci are on the same axis as our vertices, so this is going to be a change to y coordinates, not x coordinates. And so we're going to be adding 3 and subtracting 3 to the y coordinate of our center. So if we subtract 3, we get 2, negative 6, and if we add 3, oh, that's supposed to be positive 2, we get 2, 0. So we have a foci at 2, 0, and a foci at 2, negative 6. Graph the equation, list the key points of the ellipse. X minus 2 squared over 36 plus y plus 1 squared, or quantity squared, over 25 equals 1. So our center is 2, negative 1. That's our HK value. The larger value is underneath the x term. A squared is 36. That means A is plus or minus 6. So we're going to be adding 6 and subtracting 6 to the x coordinate of our center. So when we subtract 6, we get negative 4 and negative 1. When we add 6, we get 8, negative 1. Let's go ahead and graph those 3 points. So our center, 2, negative 1. Our vertices at negative 4, negative 1. And at 8, negative 1. Great. So that's the vertices and our center along the major axis. We will graph the foci on the major axis in just a minute. Co-vertices come from our B value, which in this case is 25. So B is plus or minus 5. And since that is the co-vertice, that's going to be on the perpendicular axis to the way this thing is elongated. So those are y coordinate changes. So we are going to add and subtract 5 to the y coordinate of the center. So when we subtract 5 from negative 1, we get to negative 6. And then when we add 5 to the y coordinate, we get to 4. So let's graph those. 2, negative 6. And then 2, 4. Okay, and we have an idea of what our ellipse looks like. Try to graph it as smoothly as possible. Those never quite come out as ovals the way I'd like them to. And then the foci is c squared equals a squared minus b squared. So c squared equals 36 minus 25. That means c squared is 9. C is plus or minus 3 again. This is elongated again horizontally, so that's going to be plus or minus 3 to the x coordinate in the center. So if we subtract 3 from 2, we get negative 1, negative 1. That's one of our foci. And then if we add 3 to our x coordinate, we get 5, negative 1. That is our other foci. Our next example, we have x minus 3 quantity squared over 9 plus y minus 5 quantity squared over 9 equals 1. In this case, we can clearly see that our a squared is equal to our b squared, so we do have a circle. We have a circle that has a radius of 3 because the square root of a squared is equal to the square root of b squared, which is plus or minus 3. And then our center is at 3, 5. So let's go ahead and graph our center. It comes from our HK value in the equation. And then to get the vertices and the co-vertices, they're actually going to be the same distance from the center as each other. So the vertices and the co-vertices will be the same distance from the center as each other. And then the foci is actually the center itself because it is a circle. And in the case of a circle, the foci sit on top of each other. So really, if the circle is radius 3, all we've got to do is count left, right, up, and down 3 places. So 1, 2, 3 to the right, 1, 2, 3 to the left, 1, 2, 3 up, 3 down. Oops, did not mean to leave that little mark there because our foci is actually in the center of the circle. And then we're just going to sketch our little circle. Awesome. Write an equation of an ellipse with given characteristics and the center at negative 1, 6. So since it's x minus h minus a negative 1 is going to be plus 1 squared. And then y minus 6 squared. And then equals 1. So all we need at this point is what our a and b values are equal to. So if our center is at negative 1, 6, and it says our vertex is at negative 1, 13, then the change was in the y's, right? So that means our ellipse is stretching more or elongated more vertically. And so what we need is the difference between the y coordinate of the center and the y coordinate of one of the vertices. So 13 minus 6 equals 7. That means that A is equal to 7. And because, again, that was a y coordinate change, A squared, which is 49, is going to go under the y term. For x term, it tells us that our co-vertices are at negative 7. So remember, our center was negative 1, 6. Co-vertex at negative 7, 6. So it was the x coordinates that changed. It changed by a negative, what? Negative 1 to negative 7 is negative 6. So that means b squared is 36. And we have the equation of our ellipse. For our second one, we're given the vertex. The center is still negative 1, 6. Vertex at negative 5, 6. And the focus at 1, 6. Okay. So x plus 1 squared plus y minus 6 squared all equals 1. It says the vertex is negative 5, 6. That is an x change, which means A is going to go under the x value. So the difference between negative 5 and negative 1 is 4 units. So that means that A is plus or minus 4, A squared is 16. So I'm putting 16 underneath the x plus 1 squared. I know from my foci equation that c squared equals a squared minus b squared. I know that, oh shoot, I wrote b squared there, didn't I? If a is plus or minus 4, then a squared is 16. There we go. The focus, so let me write my center point down again, is negative 1, 6, and the foci, or one of the foci, the focus is at 1, 6. And we can see how this is an x-coordinate change, which is what we expected. We already said that A was going to be underneath the x term because that's what we saw change from the vertex to the center. It was listed as the vertex, not the co-vertex. So the difference between these x coordinates is 2. So that means c squared is 4. So we've got 4 equals 16 minus b squared. B squared equals 16 minus 4. So b squared equals 12. So the equation of that ellipse is x plus 1 quantity squared over 16 plus y minus 6 quantity squared over 12 equals 1. The eccentricity of an ellipse is used to measure the ovalness of it and is just found by the ratio E equals C over A. That E is not like the number E. I hate that they used E in this case, but they used it just for eccentricity. It is not meant to represent the irrational number E. All right, last example, and this is where you guys are going to hate me again. Well, not hate me again, but we have here 4x squared plus y squared minus 8x plus 4y minus 8 equals 0. And believe it or not, this is the equation of a conic section. It is either a circle or an ellipse. So we want to identify which one it is. And then we want to find the center, the radius, the vertices, foci, eccentricity of the conic, if applicable. How are we going to do this? Every single other one we've had has been two fractions, one with x's, one with y's, and then equal to a constant. So let's go ahead and group what we've got. So 4x squared minus 8x, and then we've got y squared plus 4y. And then let's go ahead and move that 8 over to the other side. Okay. So what we have here is the potential of creating the square twice. So we're going to have to complete the square with each of these in order to write them both as binomial squareds in the fractions. In order to complete the square, you always have to make sure the leading coefficient is 1. So for this first one, we're factoring out the 4 and making it x squared minus 2x. The y squared is already positive 1. And so we're going to take half of our b value, which is the linear term coefficient, and we're going to square it. And of course, then we add that to both sides of the equation. So b in this first case is negative 2. B divided by 2 is going to be negative 1. B divided by 2 squared is going to be 1. So I'm adding 1 in the parentheses. But remember, this is going to be a 4 times 1, so when I add it to the other side, I need to add 4. For my y squared, b is 4, half of b is 2, half of b squared is 4. So I'm adding 4 here, and it's just 1 times 4, so I'm adding 4 to the other side of the equation. So at this point, I've got 4 times x. Well, it's going to be 1. We take the sign from the center, minus 1 quantity squared, plus y plus 2 quantity squared equals 16. The equations of our circles and our ellipses are supposed to be equal to 1, so we're going to divide both sides of the equation by 16. 4 over 16 gives me an x minus 1 quantity squared over 4. And then we've got a y plus 2 quantity squared over 16 equals 1. So now we are in the form of an ellipse. It is an ellipse because a and b are not equal to each other. So we have an ellipse. The center is 1, negative 2. The vertices are 1, minus 6, and 1, positive 2. So remember, we're taking the y coordinate and adding and subtracting the square root of 16 because that's what is underneath our y value. So this is vertices. Our co-vertices are going to be, well, 4, the square root of that is 2. So we are going to subtract 2 and then add 2 to the x coordinate of the center to get the co-vertices. The eccentricity requires that we have the c value, so we need to go ahead and find our foci, which is c squared equals a squared minus b squared. C squared in this case is going to be 16 minus 4. So c squared equals 12. So that means c is plus or minus the square root of 12. So to get your foci, and our a value is underneath the y, so we're going to be adding and subtracting this to the y coordinate of the center. So the foci are at 1, negative 2, plus or minus the square root of 12. Since the square root of 12 is not a rational number, I'm just going to show it that way. We know that this is an ellipse. We already said that. We were also asked if we could find the eccentricity. So the eccentricity is just equal to c over a. So in this case, it's the square root of 12 over 2. Oops, my mistake. I did not put c over a right there. I actually put c over b. A is the square root of 16, which is 4. And if you were to get a decimal approximation for that, you would get a number that is between 0 and 1.